determine when it is possible to draw a triangle with given side lengths? Think about this question during the lesson. Students in a woodshop class are measuring and cutting out a triangular base for a corner shelf, with sides measuring 6 inches, 8 inches, and 10 inches. How can you determine if all the students will cut out the same triangle? Explain. Let's see if we can find a relationship between the triangles. Does the orientation of a triangle change its shape? Use geometry software to draw and compare triangles with the given side length. You can turn the triangles so they fit exactly on each other. Do all triangles with side lengths 6 units, 8 units, and 10 units have the same shape and size?
Select your answer.
If triangles have the same side lengths, then they have the same shape and size, no matter how they are positioned. So all the students will cut out the same triangle. How many unique triangles can be drawn with given side lengths of 8 inches, 10 3/10 inches, and 13 inches?
There will only be one unique triangle with a given side lengths. It could be shown in different rotations, but once you place them on top of each other with those same side lengths, there should be all one triangle.
Steve gathers 3 pieces of wood from the scrap pile in woodshop class.
Can Steve make a triangle with these 3 wood pieces? Explain.
So we have here the 3 pieces of wood. They put it together here. And this is a simulator, so I can try to see if with these I can make a triangle. And what it looks like is one of these sides would have to be a little bit longer for us to make a triangle. So nope, we would not be able to make a triangle with these wood pieces. And so that's what they're explaining here. The 3 feet and 4 feet are not long enough to form a triangle. 3 plus 4 is less than 8. So basically, it would have to be greater than 8 at minimum to be able to make that triangle.
What are the possible lengths to complete the triangle?
So we're going to find the minimum length. And so we have 5, 6 inches. And the third side must be greater than the difference between the 2 sides. So we have 1 inch remaining to complete or make them at least equal to each other. The maximum length, you add the 2 sides together and you get 11 inches. And the third side must be less than the sum of the 2 given sides. So the maximum is 11, the minimum is 1 inch. And conclusion, the possible lengths to complete the triangle are greater than 1 inch and less than 11 inches.
Part A. Write 3 side lengths that will form a triangle. Write 3 side lengths that will not form a triangle.
So we would all have a different answer for this because it's not one specific answer for this. So an example answer would be, for not making, side lengths that will not make a triangle. We could have 3 feet, 9 feet, 10 feet. If we had these 3 sides, these would make a triangle. If we were not, let me do a different color. If for it not to make a triangle, we could do 2 feet. 2 feet, 4 feet, and 8 feet. Okay, so if we did these three, then we would not be able to form a triangle. And again, if you look back at example 2, this example 3 and example 2, it shows you that if you were to add 2 sides together, it has to be greater. And then if you were adding, you have a minimum and a maximum, and if that will help you as well. But that's how you can come up with your own 3 side lengths for a possible triangle.
Part B. What are the possible lengths to complete a triangle with side lengths of 7 feet and 13 feet?
All right, so we have 7 feet and 13. So again, going back to the example, if we were to find the difference of 7 and 13, that is 6. So 13 minus 7 is equal to 6. So this would be the minimum, okay, that it could be is 6 feet for that third length. And then the other part was to show the maximum. So you would add the 2 numbers or sides together. So 13 plus 7 is 20. So 20 feet would be our maximum. So the possible side lengths for this triangle would be, I didn't mean to zoom in, but the possible would be anywhere between 6 and 20 feet are the possible lengths for this triangle.